Right. So we have what we have found our shear stress. Okay, our expression of shear stress as a function of y. So the next thing we're going to do is we're going to find FAB. Right. So FAB is going to be, we're going to integrate the shear stress of AB, right? Then as a function of, we're going to differentiate the area, right? So this is equal to, or derivative of the area, okay? So the limits is A to 2A, shear AB, and the area, the thickness is constant, it's only dy is changing, right? The y is the one, this is the variable, okay? There is a variable that is moving, right? So from here, and you just do the math, and I can tell you this, all of you, your math is better than mine. So this is V over 2I and multiply by 4A squared 1 minus y squared t dy. Okay. So what are the constants? V t over 2I, and this is A 2A, and here 4A squared minus y squared dy. Okay. So when you integrate this is really straightforward integration. So Vi or Vt over 2I, and what we have over here is 4A squared y minus by y cubed over 3, and the limits is A to 2A. Okay. So this will be equal to Vt over 2I, right? So what we have is we're going to substitute 8A cubed, right, minus by 8A cubed over 3, okay, and then we're going to minus 4A cubed minus by A cubed over 3. So this will give us 8 minus 8 over 3 minus 4 plus by 1/3 is equal to 5 Vt over 2I, 5A cubed over 3. Okay. And then if we substitute everything including the I, so Vt over 2, and we found our I, our expression for I is equal to what? 28 over 3 A cubed T. 28 over 3 A cubed T, right? And then we multiply by 5A cubed over 3, okay? So you can cancel the T's. You can also cancel the A's, okay? So this will be equal to 5 over 3 divided by 2 divided by 28 over 3. You get 5V over 56. Okay. So this is equal to your FAB, and FAB is also equal to your FFG. Okay. So next we are going to do the same for FBD. Okay, we're going to do the same for FBD. Now let me bring down the cross-sectional view again. Then it's easier. As I told you, this is so much easier than thin wall analysis, right? What I taught last week. Okay, this is just you do the math. Okay, so now we're going to determine FBD, which is equal to FEF. Okay, we're going to determine FBD. Okay, so we are going to calculate our QBD. And the QBD, you have to consider QAB plus by QBD, and QBD is a function of Z. Okay, so this is our, again, our Y, our Z, rotation about X. Okay, so I'm going to sketch. Okay, I'm going to sketch. So what we have is we have our A. So this is our A. And then we have to include our 2A now. Right. Okay. So as I said, you have to be very clear that where we are drawing is the center line. Okay, what we are considering is a center line, or not you will get really confused, or I did get confused before. So again, this is our centroid, right? So I'm going to draw a orange to highlight the center line. Right. Okay. So we are aware that this distance from here to here, right? This is our A. And then now, okay, so the area that we have to consider is this entire area over here, right? And then we have our variable now, right? And this is our Z. Okay, and this is the area that we are going to consider. Okay, so this is our point A, our point B, and I think that is our point D. Okay, so we are going to calculate QBD. So this is equal to QAB. So just to make things easy for us, this is our width, and this is our depth, right? So QAB, the width is T, the depth is A, the Y bar is 3A over 2. Okay, and then we're going to plus the width is our Z, right? This is the Z. The depth So we are aware that this is our thickness T, and the distance is A. Okay, a lot of times students will think, hey, I have to compensate for the thickness. No, we are considering the center line, the orange thing that I've drawn. Okay, these are the center line. Okay, everything we are taking at the center line. Okay, so this is so much easier to calculate now. Okay, so it's 3/2. Okay, I'm sorry. So it's 3/2, right? A squared T plus by ATZ. Okay. So next we are going to calculate our first moment of area, or I'm going to take out the A and the T, right? So you can take out A T factor out. So 3A/2 plus by Z. Okay. Then the shear stress BD as a function of Z. So this is V over IT. The first moment of area will be equal to AT multiplied by 3A/2 plus by Z. Okay. So we realize that we can cancel the T's. So it's VA over I, right? We can have we get rid of the T's, right? So VA over I, so 3A/2 plus Z. Okay. Then we do the same thing again. We are going to find our FBD. Okay. So FBD will be equal to, we're going to integrate the limit 0 to 2A, right? So stress BD as a function of Z and DA. Okay. Now, why is it 2A? Because the distance is 2A. Okay, so 0 is on the right hand side at point B, 2A is up to D. So this will be equal to 0, 2A, right? So it's VA over I 3A/2 plus by Z. Thickness is constant, okay, dz, okay, our variable. So from here, so we know that we will integrate. So VA T over I are all constant. We integrate to have 3A/2 Z plus by Z squared over 2, and the limit is 0 to 2A. Okay, so as I say, very easy math, which you guys are better at it than me, I think. Okay. So from here, I will carry on the next page. Anyone, any questions so far? I don't see anything. So from here, this will be equal to VAT over I, and this will be equal to 3. So the 2 were cancelled, so it will be 3A squared plus by 2A squared, because Z squared 4 plus by 2A squared. Okay, and then minus 0, you can ignore the term. So this will be equal to VAT, or this will be equal to 5 BA cube T over I.